Alrighty, this is the last video for the review packet. If you have not done this page, then you'll have the same answers as me. If you've already completed it, your answers might be a little bit different. Remember, this column is just examples, where you fill in one of the variables or all of the variables and see what you get. So for the first one, x to the power 1 is equal to x, meaning anything to the power of 1 is itself. So if I had, 17 to the power 1, it's 17. Anything raised to the power of 1 is itself. Next, power of 0 means anything raised to the power of 0 is equal to 1. So if I had 143 to the power of 0, it's 1. Negative exponents is where you rewrite the exponent as a fraction and your number and exponent as the denominator. So if I had 3 to the negative 2 power, I would have 1 over 3 to the second power, or 1 over 9 if you expand your exponent. Next, the product rule means if you have two bases that are being multiplied, they're the same base and it's being multiplied and they have different exponents, you add them. So we might have 4 to the power of 3 times 4 to the power of 7. That gives me 4 to the power of 10 because 3 plus 7 is 10. You could rewrite it with 4 times 4 times 4, and then 4 times 4 times 4 times 4 times 4 times 4 times 4, and you'd have a total of 10 fours being multiplied. Power rule. Anytime you have an exponent raised to a power and then it's raised to a power again, you multiply your exponents. So maybe you would have 6 to the power of 5, all raised to the power of 2. So you would have 6 times 6 times 6 times 6 times 6, and you would write that set 2 times. Or you would multiply your exponents, giving us 6 to the power of 10. All right, when you are dividing exponents and they have the same base, you end up subtracting them. So if I had, 8 to the power of 7 over 8 to the power of 3, I would then have 8 to the power of 4 because 7 minus 3 is 4. Rewriting it, we'd have 7/8 on top and 3/8 on bottom. And when you do 8 divided by 8, they cancel out. And it would leave you with just the 4 on the top. Power of a product. So you have two numbers inside multiplying, or a number and a variable multiplying, and then you have an exponent. That exponent carries to both terms. So maybe you have 5x to the power of 3. You now have 5 to the power of 3 times x to the power of 3. And power of a quotient rule. So you have something being divided with the power on the outside. So we're going to leave a variable. Let's have x divided by 17, all raised to the power of 2. Your 2 goes to both terms. So we have x squared over 17 squared. Alrighty, on this page, I'm only going to go over probably 4 of them. The bottom ones, I'm not going to touch at all because those are power of 1, power of 0 rules. So let's go with this one. So I have negative 7 to the power of 3, negative 7 to the power of 1, and negative 7 to the power of 5. All of these have a base of negative 7, so we're going to add our exponents, giving us negative 7 to the power of 9. And then we will let's do C, where we have 3 terms and then a power on the outside. So I'm going to bring my power to everything on the inside. Give me 2 to the power of 9, a to the power of 27 because 3 times 9 is 27, and b to the power of 90 because 10 times 9 is 90. And we'll do number 4, way up here. 1 divided by w to the negative 5. Well, this becomes a fraction, so I have 1 divided by 1 divided by w to the power of 5, which ends up canceling out, giving us w to the power of 5. And let's do one more. Let's do this one way down here. 1 over w to the power of 10 is equal to w to the power of negative 10. And then when we have the power rule, when we're multiplying two bases, we add our exponents because this is negative. Negative 10 plus 25 is w to the 15th power. You should complete the rest of these. If you have questions, ask us. Next, we have scientific notation. I'm only going to go over this sheet with you, and then you can do the rest on your own. So when you have a number in scientific notation, your coefficient should be greater than 1 but less than 10. It can be 1, but it has to be less than 10. And then power of 10, and then how many decimal places you moved your decimal. If it's a negative exponent, that means you have a really small number, and it's going to be tiny. If it's a positive exponent, you're going to have a larger number. So if we look at this first one, our decimal is here. I need it to go right there so that the number is greater than 1 but less than 10. So 2.3 will be my number. And I move it. There's 3, 6, 9, and then 10. So times 10 to the power of 10. For this one, I need my decimal on the other side of the 5, so I'm going to have 5 times, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Times 10 to the negative 15. We got 2 more that I'll do with you, or 3 more I'll do with you guys. This one, our decimal will go here, because our number needs to be less than 10, greater than 1. So 3.24 times 10, and there's 3, 6, 9, 12, 13, 14. Number 4, our decimal will go there. So we have 3.4 times 10. And there's 3, 6, 7, 8. And our last one, our decimal will go between our 5 and a 6, giving us 5.6 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9. That means you have the rest of these ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then these ones, 17 plus 16 plus 10. So 26, 36, 40 some odd problems to do. These ones you're just creating into scientific notation. The others you are solving laws, exponents.